Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have triangle ABC. Actually triangle ABC is blocked by this circle. We also know that side AB of this triangle equals to 13 units. Side BC equals to 14 units. And side AC of triangle ABC equals to 15 units in its length. Again, our mission is to find out the area of this green shape. For the drawing, it is obvious that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Okay, so let's start with the first method. Actually, in the first method we have here rule number 4. According to rule number 4, you can know the area of any triangle by the following formula. According to rule number 4, the area of triangle ABC is equals to, here we have this triangle ABC. Side AB of this triangle ABC equals to 1 units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. Then the area of this triangle ABC is equals to the square root of S times S minus A times S minus B times S minus C. Here S is the semi-perimeter of this triangle ABC. The semi-perimeter is the perimeter over 2. The perimeter of this triangle ABC is equals to A plus B plus C. That's actually the sum of the side lengths. And if we divide the perimeter by 2, we'll get the semi-perimeter. So the semi-perimeter of this triangle ABC, S, equals to A plus B plus C. That is the perimeter over 2. And here side AB equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. So we can actually implement rule number 4 in our drawing. In our drawing, we define side AB of this triangle ABC as A. We define side BC of this triangle ABC as B. So B equals to 14 units and A equals to 13 units. And we define side AC of this triangle ABC as C. So C equals to 15 units in its length. And according to the new formula, the area of this triangle ABC the area of triangle ABC, here the squared brackets is the sign for the area. It means the area of triangle ABC is equals to, according to the new formula, that is rule number 4, is equals to the square root of S times S minus A times S minus B times S minus C. So the area of this triangle ABC will be equal to, so first of all, we will find out the semi-perimeter of this triangle ABC. As I already mentioned before, the semi-perimeter of triangle ABC will be equal to the perimeter, that is the sum of the side lengths, that is actually A plus B plus C, and if we divide the perimeter by 2, we get the semi-perimeter S. Okay, so the semi-perimeter S equals to A is 13 units, plus B is 14 units, plus C is 15 units, all divided by 2 will give us the semi-perimeter of this triangle ABC. So actually S equals to 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter of this triangle ABC equals to 21 units. So now the only thing that is left to do is to put the data inside the formula for the area of triangle ABC here. The area of triangle ABC equals to this expression. So I copy again. The area of triangle ABC equals to the square root of S. S equals to 21 units, times S is 21, minus A. I'll write it down here that A equals to 13, B equals to 14, and C equals to 15. Okay, so S minus A is 13, so it is 21 minus 13, times S is 21, minus B is 14, so S minus B is 21 minus 14, times S is 21 minus C is 15. So S minus C is 21 minus 15, all under the root. So the area of triangle ABC is equals to the square root of 21. We'll substitute 21 by 3 times 7, and 21 minus 13 is 8. 21 minus 14 is 7, times 21 minus 15 is 6. So the area of triangle ABC, according to the new formula, according to rule number 4, will be equal to the square root of 3 times 7. 8 is 2 times 2 times 2, so we'll substitute 8 by 2 times 2 times 2 times 7, and we'll substitute 6 by 2 times 3. So actually found out that the area of triangle ABC in total it is equal to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 and times the square root of 2 times 2. So the area of triangle ABC is equals to the square root of 3 times 3 is 3, times the square root of 7 times 7 is 7, times the square root of 2 times 2 is 2, and times the square root of 2 times 2 is 2. So in conclusion, I found out actually that in total the area of this triangle ABC is equals to 3 times 7 times 2 times 2. 3 times 7 is 21, 21 times 2 is 42, and 42 times 2 is 84. So the area of triangle ABC is equals to 84 square units. Okay, so again, the area of this triangle ABC equals to 84 square units. We actually have another rule, that is actually rule number 6, that talks about the radius of a circle that blocks triangle. According to rule number 6, the radius of a circle that blocks triangle ABC is equals to R equals to A times B times C over 4 times the area of triangle ABC that is blocked by the circle. So in the drawing we have triangle ABC. Know that side AB of this triangle equals to A units in itself, side BC equals to B units in itself, and side AC equals to C units in itself. And the radius of this circle that blocks triangle ABC equals to capital R. According to the new formula, the radius of this circle that blocks triangle ABC is equals to A times B times C. That is the multiplication of the sides of the triangle ABC that is blocked by this circle over 4 times the area of this triangle ABC that is blocked by this circle. Actually, we can implement rule number 6 in our drawing. Why? Because in our drawing we have this circle that blocks triangle ABC. So we define as the radius of this circle is capital R, and according to rule number 6, the radius capital R, point O is the center of the circle, point B is the point of the circle itself, therefore OB is the radius of this circle is equal to capital R according to our definition. So capital R, according to rule number 6, will be equal to A times B times C. And again, according to rule number 6, the radius capital R of this circle must be equal to A times B times C. That is the multiplication of the side lengths of triangle ABC by each other over 4 times the area of triangle ABC. So the radius of this circle capital R equals to A is 13, times B is 14, times C is 15, over 4 times the area of triangle ABC. And we have already found out that the area of this triangle ABC is equals to 84 square units. So we can substitute the area of triangle ABC by 84. In the next step, we divide both the numerator and the denominator of this expression by 14. And we get that the radius of this circle that blocks triangle ABC is equals to 13 times 15. 15 over 15 is 1. Over in the denominator we will have 4 times 84 over 14 is 6. Okay. In the next step, we divide both the numerator and the denominator of this expression by 3, and we get that the radius of this circle, that is to say capital R, will be equal to 13 times 15 over 3 is 5 over 4 times 6 over 3 is 2. So actually found out that the radius of this circle that blocks triangle ABC, capital R, equals to 13 times 5 over 4 times 2. 13 times 5 is 65 and 4 times 2 is 8. So in conclusion found out that the radius of this circle, that is to say capital R, equals to 65 over 8 units. Our mission is to find out the area of this grain shape. So as I mentioned before, it is very clear from the drawing that the area of the grain shape is equal to the area of the circle minus the area of triangle ABC. Repeat again, the area of this green shape, so though it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of this circle is pi r square, pi times the radius square, minus the area of triangle ABC. We have already found out that the area of this triangle ABC equals to 84 square units. So it is 84 square units. So it is pi times r square. R is 65 over 8, therefore r square is 65 over 8 square, minus the area of triangle ABC is 84 square units. So this expression, pi times 65 square, pi times 65 over 8 square, in total it is equals to 207.394 square units. Minus the area of triangle ABC, that is 84 square units. So 207.394 minus 84 is equals to the area of the green shape, that is actually 123.394 square units. Okay, I repeat again. The area of the green shape in total is equals to 123.394 square units. And that is the answer to the question. The area of this green shape, it is equal to 123.394 square units. So we finished with the first method. In the next step, I'll present to you how to find out the area of this green shape according to the second method. In the second method, we'll do a construction, that is to say from point A we draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A inside BC as M. It is given us in the question that side BC equals to 14 units. So we define side BM as X. So note that BC in total equals to 14 and BM equals to X. Therefore, the missing side MC must be equal to BC minus BM. BC is 14 and BM is X. So MC equals in total to 14 minus X. Okay, again, MC equals to BC minus BM. BC is 14, BM is X, so in total MC equals to 14 minus X. So in the next step, we will implement the Pythagoras theorem on the right triangle ABM. So I copy the right triangle ABM in a new page and we will implement on it the Pythagoras theorem. We define side AM as edge and side BM equals to X, also according to our definition. Side AB equals to 13 units in itself according to what is given us in the question. So actually, this is triangle ABM that I copied from the original drawing. Side AM equals to H, according to our definition. Side BM also equals to X according to our definition also. And side AB equals to 13 units, according to what is given us in the question. Here by PT is the evaluation for Pythagoras theorem. So in this triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared, this will be equation number 1, AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169. And it is equals to AM squared. AM is 8, therefore AM squared is 8 squared plus BM squared. BM is X, therefore BM squared is X squared. So here we subtract X squared from this equation. And you get that according to equation number 1, X squared equals to 169 minus X squared. In the next step, I will copy the right triangle AMC in a new page and we will implement on this right triangle AMC the Pythagoras theorem. Right triangle AMC. Side AM equals to H, according to our definition. Side MC equals to 14 minus X. and side AC equals to 15 units according to what is given as the question. So actually, this is the right triangle AMC that they call it from the original domain. By PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle AM, this is the right triangle AMC that I call it from the original domain. Here by PT is a relation for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle AMC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AC, therefore the square of the hypotenuse is AC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AM squared plus MC squared. So according to equation number 2, this equation number 2, AC squared, AC is 15, therefore AC squared is 15 squared, that is 225. That is equals to AM squared. AM is 8, therefore AM squared is 8 squared plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. So here we'll open the brackets on this side of equation, this equation number 2, and we get that according to equation number 2, 225 equals to 8 squared. So actually, we subtract 14 minus x squared from this equation number 2, 14 minus x squared, and therefore we get that according to this equation number 2, 225 minus 14 minus x squared equals to 8 squared. So we have actually two different expressions for x squared. According to this equation number 2, x squared equals to 225 minus 14 minus x squared, while according to equation number 1, this equation number 1, x squared equals to 169 minus x squared. So in the next step we'll get equation number 3. According to equation number 3, x squared according to equation number 1 must be equal to, again, 8 squared according to equation number 1 must be equal to 8 squared according to equation number 2. Repeat again, equation number 3 states that 8 squared according to equation number 1 must be equal to 8 squared according to equation number 2. So, x squared according to equation number 1 equals to 169 minus x squared, and it must be equal to 8 squared according to equation number 2. 8 squared according to equation number 2 is equals to 225 minus 14 minus x squared. So here we'll open the brackets on this side of this equation number 3, we get that according to equation number 3, 169 minus x squared equals to 225 minus, inside the brackets we have 14 minus x squared. 14 minus x squared equals to 14 squared, that is 196. plus x squared minus 2 times 14x is minus 28x. So according to this equation number 3, we actually found out that 169 minus x squared equals to 225. Here we'll open the brackets and we get here this will be equal to minus 196. Where minus and plus is minus, so it is minus x squared. And we have here minus with minus is plus, so it is minus times minus 28x equals to plus 28x. So here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. So if we found out that 169 inside of the equation, we left only with 169. That is equals to 225 minus 196 is 29 plus 28x. Here we subtract 29 from this equation number 3, and we get that 169 minus 29 is 140. That is equal to 28x. Here we divide this equation by 28, and we get that x equals to 140 over 28 is 5. So x equals to 5 units in its length. Now we'll put the value of x inside equation number 1. According to equation number 1, x squared equals to 169 minus x squared. So it is 169 minus x squared, but x is 5, therefore x squared is 5 squared, it is 25. So actually found out that x squared equals to 169 minus 25, that is actually 144. Repeat again, x squared equals to 144. Here we take a root out of this equation and we get that according to this equation number 1, h equals to the square root of 144, that is 12. So we found out that h, that is the height to the base, if h is height to the base BC, of triangle ABC, is equals to 12 units in its length. Okay. So in the next step, we define the center of this circle as O. We join points A and O together by a straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as capital R. We will extend the radius AO, that is equal to capital R according to our definition, by a straight line until it touches the circle, and we define the touching point of the extended radius AO and this circle as point P. We have here chord AP that passes for the center of this circle, that is to say it passes for point O, that is the center of the circle. And we know that any chord that passes for the center of the circle must be the diameter of the circle. Therefore, chord AP is the diameter of the circle. I write it down here that AP is the diameter of the circle. And the radius of this circle is defined as capital R, therefore the diameter must be twice as long as the radius, that is to say, AP must be equal to 2 times capital R. AP, that is the diameter of the circle, must be equal to 2 times capital R. Okay, AP equals to 2 times capital R. We will join points P and C together by a straight line. By joining points P and C, we created the peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we also know that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Therefore, peripheral angle ACP that rests on AP, that is the diameter of the circle, must be equal to 90 degrees. Repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. Here we have this peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore, this peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. And indeed, this peripheral angle ACB is equal to 90 degrees. Therefore, we can implement actually rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, this peripheral angle ACP, according to rule number 7, must be equal to 90 degrees. Okay, so we have here peripheral angle APC rests on AC, and we have also peripheral angle ABC that rests on the same chord called AC. So those two peripheral angles, they are both rest on the same chord called AC. And we have here rule number 8 that relates to two peripheral angles that rest on the same chord. According to this rule number 8, peripheral angles that rest on the same chord are equal to each other. Those two peripheral angles, angle ADB rests on chord AB, and the peripheral angle ACB rests also on the same chord called AB. Therefore, they are equal to each other. That is to say, if peripheral angle ACB equals to theta, then peripheral angle ADB must be also equal to theta. Okay, we can actually implement rule number 8 in our drawing. Why? Because in our drawing, we have peripheral angle APC that rests on chord AC. So if we define peripheral angle APC as theta, so here we have peripheral angle ABC that rests on the same chord called AC. Therefore, it also must be equal to theta. Okay, I repeat again. According to rule number 8, those two peripheral angles that rest on the same chord that is actually called AC must be equal to each other. So if this peripheral angle APC is theta, then this peripheral angle ABC must be also equal to theta, according to rule number 8. So we'll focus on the right triangle, triangle ABM. In this right triangle, triangle ABM, in the right triangle, triangle ABM, this angle equals to 90 degrees, this angle equals to theta. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the sum of the angles in any triangle. Likewise, we'll focus on the right triangle, triangle ACP. On the right triangle, triangle ACP, this angle equals to 90 degrees, this angle equals to theta, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the right triangle, triangle AMB, is similar to the right triangle, triangle APC. So I'll write it down. We prove that the right triangle, triangle AMB, is similar to the right triangle, triangle APC. Triangle, right triangle AMB similar to the right triangle, triangle ABC. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So I write it down. Angle ABM in this triangle is equal to this angle, is actually angle APC. Repeat again. Angle ABM in triangle ABM equals to angle APC in triangle APC. They are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AMB, triangle AMB, this angle equals to this angle is actually angle ACP, triangle ACP. Repeat again. Angle AMB, triangle AMB equals to angle ACP, triangle ACP. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this angle is angle BAM. And it is equal to this angle that is actually angle PAC. Repeat again. Angle BAM in triangle AMB equals to angle PAC in triangle APC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually all the three angles in this triangle, triangle AMB are correspondingly equal to all those three angles in triangle APC. Therefore we actually proved that this triangle, triangle ABM is similar, this is the sign of similar, to triangle APC according to angle similarity rule. And from the fact that triangle AMB is similar to triangle APC, we derive that the following relationship exists between their sides. We conclude that AM in triangle AMB over AC in triangle ACP equals to AB in triangle AMB over AP in triangle APC. Repeat again. We'll derive that AM over AC equals to AB over AP. AM is 12 over AC is 15, and it is equals to AB is 13 over AP is the diameter of the circle, that equals actually to 2 times capital R. In conclusion, we found out that 12 over 15 equals to 13 over 2 times capital R. Here we cross multiply this equation and we get that 2 times capital R times 12 equals to 13 times 15. Here we will divide this equation by 12 and also by 13, and we get that 2R over 15 equals to 2R over 15 equals to 13 over 12. Actually, we divide this equation only by 12 and we get that 2R equals to 13 times 15 over 12. And again, I found out that 2R equals to 13 times 15 over 12. Here we divide this equation by 2, and finally we get that capital R, that is the radius of the circle, equals to 13 times 15 over 2 times 12. Here we divide both the numerator and the denominator of this expression by 3. And we get that R, that is the radius of the circle, equals to 13 times 15 over 3 is 5 over 2 times 12 over 3 is 4. So in total, the radius of the circle equals to 13 times 5 is 65 over 2 times 4 is 8. So the radius of the circle R equals to 65 over 8. Now it is very easy to find out the area of the circle. The area of the circle must be equal to pi r squared. And the area of the green shape in total from the drawing it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. Is equals to the area of the circle minus the area of triangle ABC. So the area of the circle equals to pi r squared minus the area of triangle ABC. The area of this triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h, over 2. And again, the area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h, over 2. So it is equals to pi r squared. R is 65 over 8, therefore r squared is 65 over 8 squared. Minus BC is 14 times 8, that is 12 over 2. This expression, pi times 65 over 8 squared in total, is equals to 207.394 square units, minus, here we have 14 over 2 is 7, and 7 times 12 is 84. So the area of the green shape equals to 207.394 minus 84, that is actually 123.394 square units. Repeat again, we found out that the area of this green shape equals in total to 123.394 square units. We finished in the second method. In the next step, I'll summarize the lecture. We start with the first method, of course. So, in the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of this triangle equals to 13 units in itself, side BC equals to 14 units in itself, and side AC equals to 15 units in itself. Our mission is to find out the area of this green shape. It is obvious from the drawing that the area of the green shape must be equal to the area of the circle minus the area of triangle ABC. Okay, in the first method, we actually used rule number 4. Used rule number 4 in order to find out the area of this triangle, triangle ABC. According to rule number 4, the area of triangle ABC is equals to, here, this is the sign for the area, the square bracket. The area of triangle ABC equals to the square root of S times S minus A times S minus B times S minus C, all under the rule. S is the semi-perimeter of any triangle. Here we have triangle ABC, and here the semi-perimeter of any triangle equals to the perimeter over 2. The perimeter of this triangle, triangle ABC, is the sum of the length of its sides, that is to say, it is A plus B plus C. And if we divide the perimeter by 2, we get the semi-perimeter. So S is the perimeter that is A plus B plus C over 2. Okay? So, actually, we found out so here the area of triangle ABC equals to this expression, to this formula. In the first place, we found out the semi-perimeter of this triangle, triangle ABC. This is actually the perimeter that is A plus B plus C over 2. Here we defined side A of this triangle is AB is A, that is equal to 13. BC is B, that is equals to 14, and AC is C, that is equals to 15. Okay? So A is 13, B is 14, and C is 15, all divided by 2. So S equals to 13 plus 14 is 27, and 27 plus 15 is 42, and 42 over 2 is 21. So in conclusion, we found out that the semi-perimeter of this triangle, triangle ABC, is equals to 21 units. Here, S equals to 21 units. And we know that A equals to 13, B equals to 14, and C equals to 15. the only thing that is left to do is to put the data inside this formula in order to find out the area of this triangle ABC. So according to rule number 4, that is, this new formula, the area of this triangle ABC equals to the square root of S is 21. Again, S is 21 minus 8, that is 13. So S minus A is 21 minus 13 times S is 21 minus B is 14. So S minus B in total is 21 minus 14 times S, that is 21 minus C, that is 15. So in total S minus C equals to 21 minus 15. Okay, so the area of triangle ABC equals to the square root of 21, and 21 minus 13. So here actually 21 minus 13. But first of all, we substitute 21 by 3 times 7. And 21 minus 13 is 8. 21 minus 14 is 7. And 21 minus 15 is 6. So here we have the area of triangle ABC equals to the square root of 3 times 7. And here we have 8. We substitute 8 by 2 times 2 times 2 times 7 times 6. And we substitute 6 by 2 times 3. Total, we got this expression. So the area of triangle ABC in total will be equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2. Okay, and we know that the square root of 3 times 3 is 3, the square root of 7 times 7 is 7, and the square root of 2 times 2 is 2. Again, the square root of 2 times 2 is 2. So in conclusion, we found out that the area of triangle ABC is equals to the area of triangle ABC in total is equals to 3 times 7 times 2 times 2. 3 times 7 is 21, 21 times 2 is 42, and 42 times 2 is 83. So in conclusion, we found out that the area of this triangle ABC, it is equals to 84 square units. Then I presented to you rule number 6. According to rule number 6, the radius of a circle that blocks triangle ABC is equals to capital R. The radius capital R equals to A times B times C over 4 times the area of this triangle ABC. I repeat again that side AB in this triangle ABC equals to units in itself, side BC equals to B units in itself, and side AC equals to C units in itself. So the radius of this circle that blocks triangle ABC will be equal to the multiplication of the side depths of the triangle by each other, that is to say it is A times B times C, over 4 times the area of this triangle ABC that is blocked by this circle. Okay, so we can actually implement rule number 6 in our drawing. Why? Because in our drawing we have this circle that blocks triangle ABC. Therefore, the radius of this circle that we defined as R, as capital R, must be equals to A times B times C over 4 times the area of this triangle ABC. And then again, the radius of this circle that blocks triangle ABC must be equals to A times B times C over 4 times the area of triangle ABC. A is 13, B is 14, and C is 15 over 4 times the area of triangle ABC. And we have already found out that the area of triangle ABC is equals to 84 square units. According to this formula, we've already found out that the area of triangle ABC is equal to 84 square units. So substitute the area of triangle ABC by 84. So here we divided both the numerator and the denominator of this expression by 14. 14 over 14 is 1, so in the numerator we left only with 13 times 15 over 4 times over 4 times, and we have here 84 over 14 is 6. So in total the denominator we left only with 4 times 6. In the next step we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in total the numerator will have 13 times 5 over 4 times 6 over 3 is 2. So in the denominator we left only with 4 times 2. Repeat again. In the numerator we left only with 13 times 5, and the denominator we left with 4 times 2. 13 times 5 is 65, and 4 times 2 is 8. So in total we found out that the radius of this circle that blocks triangle ABC, the radius capital R, equals to 65 over 8 units. As I already mentioned before, the area of this green shape, from the drawing it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r squared. R is the radius of the circle that equals to 65 over 8 minus the area of triangle ABC. We already found out that the area of triangle ABC equals to 84 square units. So the area of the green shape equals to pi r squared. R is 65 over 8, therefore r squared is 65 over 8 squared. So in total the area of the circle equals to pi times 65 over 8 squared minus the area of triangle ABC, that is 84 square units. This expression in total, pi times 65 over 8 squared, equals to 207.394 square units minus the area of triangle ABC, that is 84 square units. 207.394 minus 84 equals to 123.394 square units. So actually found out that the area of this green shape according to the first method is equals to 123.394 square units. We finished with the first method. In the next step I presented to you how to find out the area of this green shape according to the second method. In the second method, we did a construction. That is to say, from point A we do perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A, in BC as M. Okay, and then we actually implemented the Pythagoras theorem on the right triangle AMB and then on the right triangle AMC. But first of all we defined side AM as H, we defined side BM as X. In total BC equals to 14. And according to our definition, BM equals to X. So the MC side MC must be equals to BC minus BM. BC is 14, BM is X, so in total MC must be equal to 14 minus X. So I copied the right triangle ABM in a new page and we implemented on this right triangle ABM the Pythagoras theorem. This is the right triangle ABM that I copied from the original domain. Side AB equals to 14 itself, AM equals to 8 according to our definition, and BM equals to X according to our definition also. In the right triangle ABM, by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ABM, AB squared equals to AM squared plus BM squared. AB is 13, therefore B squared is 13 squared, that is 169, and it is equals to AM squared. AM is 8, therefore AM squared is 8 squared, plus BM squared. BM is X, therefore BM squared is X squared. So, in conclusion, we found out that according to equation number 1, 169 equals to X squared plus X squared. Here we subtracted X squared from this equation, and finally we found out that according to this equation, equation number 1, 8 squared equals to 169 minus X squared. Then I copied the right triangle AMC in a new page and implemented on this right triangle AMC the Pythagoras theorem. This is the right triangle AMC that I copied from the original drawing. AM equals to 8 according to our definition, MC equals to 14 minus X, and AC equals to 15 minutes according to what is given as the equation. By PT is the relation from Pythagoras theorem, and this right triangle ABC AMC according to the Pythagoras theorem, AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225, and it is equals to AM squared. AM is 8, therefore AM squared is 8 squared, plus MC squared. MC is 14 minus X, therefore MC squared is 14 minus X squared. So if we found out that according to equation number 2, 225 equals to 8 squared plus 14 minus X squared. Here we subtracted 14 minus X squared from this equation, and finally found out that according to this equation number 2, 225 minus 14 minus X squared equals to 8 squared. Again, 8 squared equals to 225 minus 14 minus X squared. Okay, again, 8 squared according to this equation number 2, 8 squared equals to 225 minus 14 minus X squared. This is according to equation number 2, but we already found out that according to equation number 1, 8 squared equals to 169 minus X squared. So we have two different expressions for 8 squared. Therefore, we created equation number 3 that states that 8 squared according to equation number 1 must be equal to 8 squared according to equation number 2. So 8 squared according to equation number 1, 8 squared according to equation number 1 is 169 minus X squared, and it must be equal to 8 squared according to equation number 2, but 8 squared according to equation number 2 is 225 minus 14 minus X squared. So we opened the brackets on this side of this equation number 3, and we found out that according to this equation number 3, 169 minus X squared equals to 225 minus 14 minus X squared equals to 14 squared, that is 196, plus X squared minus 2 times 14X, that is minus 28X. So we found out that 169 minus X squared equals to 225. We open the brackets here. It is minus 196 minus X squared, and minus times minus is plus. So here it will be plus 28X. So we have X squared on both sides of the we have minus X squared on both sides of the equation, so minus X squared will get cancelled. And 225 minus 196 is 29, plus 20X equals to 169. We subtracted 29 from this equation, we found out that 169 minus 29 is 140. It's equal to 28X. Here we divided this equation by 28, and finally found out that X equals to 140 minus 28 is 5. 120 over 140 minus 28 is 5. So X equals to 5 units. Then, according to equation number 1, X squared equals to 169 minus X squared. Now we can substitute X by 5. We did it, and we got that X squared equals to 169 minus X squared. X is 5, therefore X squared is 5 squared, that is 25. So this expression equals to 169 minus 25, that is 144. So actually found out in conclusion that h squared equals to 144. We took a root out of this equation and finally found out that h equals to the square root of 144, that is 12. So h equals to 12 units in itself and s equals to 5 units. Here h equals to 12 and here x equals to 5. Then we did the construction. We defined the center of this circle as O, and we joined points A and O together by straight line. Point O is the center of the circle, point A is the point on the circle itself. Therefore, OA is the radius of this circle that we defined as R. Then we extended the radius OA by straight line until it touches the second point P. Chord AP passes for point O, that is the center of the circle, and any chord that passes for the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. Then again, AP is the diameter of the circle that equals to 2 times the radius. That is to say, 2 times capital R. Because R, capital R is according to our definition, is the radius of the circle. So AP, that is the diameter of the circle, equals to 2 times capital R. Okay, then we join points P and C together by straight line. By joining points P and C, we created a peripheral angle ACP. Peripheral angle ACP rests on AP, that is the diameter of the circle. And we have the rule that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Therefore, peripheral angle ACP that rests on AP, that is the diameter of the circle, must be equal to 90 degrees. Okay, again, this is actually rule number 7. According to rule number 7 is if a peripheral angle rests on the diameter of the circle, it is equal to 90 degrees. Therefore, this peripheral angle ACP that rests on AP, that is the diameter of the circle, must be equal to 90 degrees. So here we have peripheral angle we have peripheral angle ABC. This peripheral angle ABC rests on AC, but we have also peripheral angle APC that rests on the same chord called AC. Therefore, those two peripheral angles that rest on the same chord must be equal to each other. Here we have actually rule number 8. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have peripheral angle ADB rests on chord AB, and peripheral angle ACB also rests on the same chord called AB. Therefore, those two peripheral angles must be equal to each other. This is to say, if peripheral angle ADB, this angle equals to theta, then the other peripheral angle ACB must be also equal to theta. Why? Because of the fact that those two peripheral angles rest on the same chord called AB. We can implement rule number 8 in our drawing. Why? Because in our drawing, we have peripheral angle ABC that rests on chord AC, and we also have peripheral angle APC that rests on the same chord called AC. Therefore, those two peripheral angles must be equal to each other. Why? Because they both rest on the same chord called AC. So if this angle peripheral angle ABC equals to theta, then this peripheral angle APC must be also equal to theta. So we focus on the right triangle ABM. In this right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees, that is the sum of the angles in any triangle. Likewise, we focus on the right triangle APC. In this right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we proved that the right triangle ABM is similar to the right triangle APC. Why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually succeeded to prove that those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that AM in triangle AMB over AC in triangle ACP equals to, again, AM in triangle AMB over AC in triangle ACP equals to AB over AP. Repeat again. AM over AC equals to AB over AP. AM over AC equals to AB over AP. AM is 12, AC is 15, AB is 13, and AP is 2 times capital R. This is actually the AP is the diameter of the circle. It is 2 times the radius. So here, of course, multiply this equation and found out that 2 times R times 12 equals to 13 times 15. Then we divided this equation by 12 and found out that that 2R equals to 13 times 15 over 12. The next step we divided this equation by 2 and finally we found out that capital R, that is the radius of this circle, is equals to 13 times 15 over 2 times 12. Here we divided both the numerator and the denominator of this expression by 3. 15 over 3 is 5, so in total in the numerator we have 5 times 13, and here we have 12 over 3 is 4, so in total in the denominator we have 4 times 2. 13 times 5 is 65, and 4 times 2 is 8. So the radius of this circle capital R is equals to 65 over 8 units. The area of the green shape, the area of this green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape in total, it is equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r squared minus the area of triangle ABC. The area of this triangle ABC equals to the base of the triangle that is BC times the height to the base that is 8 over 2. Repeat again, the area of triangle ABC equals to the base that is BC times the height to the base that is 8 over 2. So it is pi r squared. R is 65 over 8, therefore r squared is 65 over 8 squared. So the area of the circle equals to pi times 65 over 8 squared. Minus BC is 14 times 8, that is 12 over 2. So this expression in total equals to 207.394 square units. And this expression is 14 over 2, that is 7, and 7 times 12 is 84. So in total, the area of triangle ABC equals to 84 square units. 207 minus 394 minus 84 is 123.394 square units. So in conclusion, we found out that the area of this green shape according to the second method, also it is equals to 123.394 square units. Okay, so in both methods we found out actually that the area of this green shape equals to 123.394 square units. Okay, thank you very much.